Hello. A GATE 2019 question from set 1 is solved. The problem statement is given. We'll try to write the data given. The first data given is mass of air, which is equal to 1 kilogram, and initial temperature is 300 Kelvin. This is also equal to the final temperature because it expands isothermally. And the initial pressure is 10 bar. The final pressure is 1 bar. Gas constant is given as 0.287 kilojoules per kilogram Kelvin. And our aim is to find out what is the change in entropy, abbreviated as or given as symbol ds, change in entropy, ds. So what is the solution? First, we will represent the problem statement in a TS diagram. There is 1 kg of air, which is initially at state 1. And this air is allowed to expand isothermally to state 2. Since it is an isothermal expansion, on a TS diagram, the graph is a horizontal line. What is the entropy at state 1 and what is the entropy at state 2? If you find the difference between S1 and S2, it gives the change in entropy. That is what we need to find. And in the solution, we know change in entropy is equal to dq divided by T. Temperature T is given as 300 Kelvin. But what about this dq? It's not given directly. Suppose if you are able to calculate dq from the other data given, then we may find the required quantity change in entropy of air ds. How can we calculate dq? The system, that is air, that is 1 kg of air, has undergone a process, or it has undergone a change of state. We can apply first law, and this ds is equal to s2 minus s1. First law is dq is equal to du plus dw for a system undergoing a change of state. This first law can be rewritten as dq equal to dw. How? Because it's an isothermal process. Internal energy is a function of temperature only, and hence dE equal to 0. Therefore, to find the quantity dq, to calculate change in entropy, we need to find the work transferred during the process 1 to 2. We know for an isothermal process, work done between the end states 1 and 2 is given by the formula P1 V1 ln P1 by P2. V1 is not given in the problem statement, but we can find from the given data. We know for an ideal gas, PV is equal to RT, and this V is a specific volume. When you apply this ideal gas equation at state 1, we can write V1 equal to RT1 divided by P1. Substitute the values. The value of R is 0.287 and T1 is 300 and P1 is 10 bar. The 10 bar is converted into Newton per meter square by multiplying it with 10 power 5. Again, we are dividing that one by 1000. for unit consistency. What is that unit consistency? We will discuss in a while. And calculation of this one yields V1 is equal to 0.086 meter cube per kilogram. Now the consistency in unit of R is kilojoules per kilogram Kelvin, and unit of temperature is Kelvin. And in the denominator, pressure unit is kilonewton per meter square. In order to convert into kilonewton, we divide it by 1000. We can cancel Kelvin. In the numerator, kilojoules can be expressed as kilonewton meter divided by kilogram divided by kilonewton per meter square. This yields the unit as meter cube per kilogram. So we know V1 also. So V1 is calculated, and hence W122, which is also equal to Q for an isothermal process, is equal to P1 is 10 into 10 power 2. This one is to convert into kilonewton per meter square. And this 0.086 is the V1 specific volume just now we calculated. And ln P1 by P2. So P1 is 10, P2 is 1, which yields W122 is equal to 192.02 kilojoules per kilogram. Of course, we are interested in calculating what is a entropy change during this process. And that entropy change is equal to dq divided by T. We calculated Q over here, substitute the value. So ds is equal to 198.02 by the temperature at which the process takes place. That is an isothermal process, which is equal to 300 Kelvin. Calculation of that one yields ds is equal to 0.66 kilojoules per kilogram Kelvin. Thank you.